Hi, guys.
How are you?
Good, man. How's everybody?
Good, how are you?
I'm styling, man. Got so much stuff going on. Okay, hey, here's what I want to do. We're going to do something new and original. How's that sound? Sorry, man. I'm on it. I'm on it. There's too many. Okay, guys. I'm Moodle. I'm Moodle is this quiz. I want you to do it right now, okay? And email it to me. Take 6 minutes.
And just email it to you said?
Yeah.
All right.
Take a picture and email me.
Could you put it back up? I was having trouble trying to read it.
It's
Yeah.
on Moodle. How come nobody's emailing me?
Trying to work on the problem.
I have a quick question. So are there like any specific points like on the graph?
No.
So like there's no anywhere that you should put like the specific intercept or anything?
No.
Okay.
Make it up. All right. I used that time to figure out how to turn the alerts off. Jesus Christ. All of a sudden, my computer was going ding, ding, ding. God, what a stupid thing this was to do. Okay, so we're wrapping this up, right? Okay, let's get to work. Screen share. God, what is all this crap that comes up? Don't want this. Don't want this. Don't even want this. Share this. Okay, everyone. So chapter 2, PowerPoint. This is the Wooldridge chapter 2. We left off right around slide 30, I think. Yeah, you can see my PowerPoint.
No, it's on Moodle.
What the hell is wrong with these things? Thank you for telling me that. Now you can see it.
Yeah, it's good now.
Okay, thank you. So we were in chapter 2. We're going to wrap this up today. Oh, we should have an exam. We'll talk about that when we're done. So we were doing this, right? And of course, this is the picture that you should have just sent me, probably something similar to this, right? So we were looking at all this stuff. We looked at the assumptions for the linear regression model, right? Assumption 1 and 2, 3 and 4, and we were here. Yeah, unbiasedness. So the interpretation of unbiasedness, the estimated coefficients may be smaller or larger depending on the sample that is a result of a random draw. However, on average, they will equal the characterizer in the population. Yeah. So on average means if sample is repeated. So where are my notes? Let's have a look at my notes. A new share. Here. My notes, Wooldridge. Unbiasedness. On average, over many draws, the estimates will equal the true values in the population. So your estimate of beta sub 0 will equal beta sub 0. Your estimate of beta sub 1 will equal beta sub 1. Does that make sense to everybody? That's the definition of unbiasedness. Okay, so if you do a draw over and over and over again, on average, they will equal the values that characterize the relationship between y and x in the population, okay? Variance of the OLS estimators, and this is where we left off. Depending on the sample, estimates will be nearer or further away from true values, right? So remember, you're estimating beta sub 0 and beta sub 1. How far can we expect the estimates to be away from true population variance? On average. So the variance of beta sub 0 and beta sub 1. Assumption 5 of the simple linear regression model, we assume homoscedasticity. The variance of your error term, conditional on the value of your independent variable x, is sigma squared, or simply variance, or simply a constant variance. The value of the explanatory variable must contain no information about the variability of the error term. Okay? That makes sense, right? In other words, in my notes, I would say if we were in class, I would write this on the board. Homoscedasticity. The error has the same variance given any value of the explanatory variable. So the variance of error term u conditional on x is equal to sigma squared. Makes sense, right? Here's a picture of homoscedasticity. Notice we have a regression line. These variability of the error term does not depend on x. See, these are all the same. Contrast that to heteroscedasticity, where they are not the same, right? Homo the same, hetero they're not. So the variance of the unobserved determinant of wages, unobserved as in the error term, is all over the place here. Yeah. So let's look at what I would write in class for your notes. Constant variance, that's homoscedasticity. Heteroscedasticity. Variance of your unobserved determinants of wage increase with level of education, i.e. unobserved, things that affect our regression that we haven't explicitly accounted for. Those are the things in the error term, right? Okay. The variance of these OLS estimators. Oh, sorry. So I don't need you to know this. Under assumptions, simple linear regression 1 through 5, the variance of beta sub 1 and the variance of beta sub 2. Like I say, this isn't so important. The sampling variability of the estimated regression coefficients will be higher the larger the variability of unobserved factors, and lower the higher the variation in the explanatory variables. Yeah, so let me tell you what I would write on the board. Same slide. The larger the error variance, the larger is the variance of your estimate of beta sub 1. The larger the variance of the independent variable, the less the variance of beta sub 1. As an aside, a larger sample size also means a smaller variance of beta sub 1. So basically what I'm trying to tell you is the larger your error variance, the larger the variance of your estimate of the slope. The larger the variance of your independent variable, i.e. x, yeah? If you have an x with a big variance, you're going to have less variance in your estimate of the slope. Okay? That's what that's all about. Estimating error variance. Variance of the error term does not depend on x. We said this is an assumption. The variance of the error term conditional on x is equal to the variance, right? Homoscedasticity. The variance of errors by calculating variance. So the residual, unfortunately, this would be biased. An unbiased estimate. So look at what's different here. Can you guys tell me? There's no difference here, right? All we're doing is putting in a degrees of freedom there, right? We have n, 1 over n, and then here 1 over n minus 2. Why is it n minus 2? Anybody? We're taking the biasness out of this by putting in a degrees of freedom adjustment. Yeah, as you might have learned in statistics, right? When you use a sample and you do an estimate, you divide by 1 over n minus 1, right? Usually. Why are we doing L over 1 over n minus 2?
So you can subtract 2.
Say it again, Dejo.
So you can subtract 2.
Yeah, we're subtracting 2. That's exactly right. How come 2?
Because
What
you
are we
can-
estimating when we run a regression? Now, not all at once, please. Zoom can't handle it. We're estimating beta sub 0 and beta sub 1. Yeah, we're estimating in a regression equation the intercept and the slope, right? The intercept is beta sub 0 and the slope is beta sub 1. We divide it by n over 1 minus 2 because we're estimating two different things. Okay, it's a degrees of freedom adjustment because we're estimating from a sample. Unbiased estimate of error variance. Oh. All right, let's go here. Because this is the last slide, okay? I feel like, here's my notes. Errors and residuals. This is the same slide effectively, but this is a little digression here. Y sub I is equal to beta sub 0 plus beta sub 1 x sub I plus some error term. Yeah, this is our regression equation. Error is in the population parameters. So U sub I, as in just by itself, that's an error term in the population parameters. We're estimating what goes on in the population by using a sample. Residuals will show up in our sample estimated equations. This is an estimate of the error term given our regression equation, right? So this could be y is equal to beta sub 0 plus beta sub 1 x sub I plus u sub I. It's just been rearranged. And the hat means these are estimates. Yeah, so if you took this this value up here and substituted it in for this, you would have this. The expected value of beta hat sub 0 is beta sub 0, and beta hat sub 1 is beta sub 1. U hat is not the same as U without a hat, because in the population, these are error terms. In the sample, this is an estimate, and it's called a residual. Okay, that's why I was hesitant to go there, but I did anyway. So the unbiasedness of the error variance, the expected value of our estimate is equal to the variance, and then we calculate standard errors. I don't need you to know this. I need you to know that the standard error is a measure of the variability of this. Yeah? They measure how precisely the regression coefficients are estimated. Maybe I should do this. Maybe I should do this. Okay, hang on. Just bear with me. This PowerPoint is over, okay? Sorry. The PowerPoint for this chapter is over. But I'm getting a lot of blank looks, and it scares me. So I'm going to share a whiteboard and maybe do this. Here's what we're talking about. Maybe this is study time. Study time. Maybe this is your exam score. I've got 42 students. These are a plot of the amount of time they spent studying and their exam score. Okay? I'm running a regression. This is alpha or beta sub 0. The slope of this line is beta sub 1. This is your y, your dependent. This is x, independent. You know all these values. What you're looking for is the relationship. You want to say to the dean, hey, if you spent 20 hours studying for Gallagher's exam, you're going to get an 85 based on last year's class. Is that clear? Is that, anybody ever play with an Etch-a-Sketch? Okay, we have reached 2020 the 21st century and I'm teaching on a freaking Etch-a-Sketch. That's what this is all about, okay? So let's go back to my picture. This distance between each one of these is u. The sum, sorry. Oh, sorry. U squared. You minimize that to fit this line. Yeah? So these are all your U's. So the variability of these data points, if they were really variable, then you wouldn't be so sure to say this is an accurate representation. Do you know what I'm saying? That's what we were talking about in the last slide. The variability of beta sub 0 and beta sub 1. Okay? That's what this is all about. All right. We're going to do some more cool things, as if we haven't already done enough cool things today. We're going to go into groups. And each group work on each of the problems. So what time is it? 3:06 already. Jesus. I do 1, 2, and 6 in your little groups. Yeah. And then we're going to come back and we're going to look at 3 all together. Okay. So 1, 2, and 6 talk about in your groups.
Professor Gallagher, is this under chapter 2 problems?
Yeah. Yeah.
All right, awesome. Thank you. Seriously?
Okay, how was your time in the breakout rooms? Was it fun? I could feel my ears burning, so I thought maybe you were talking about me. God, doesn't anybody have a sense of humor anymore? What's going on? Hey, does anybody know any jokes? You know the joke I always tell every year, I tell the same joke, right? Why can't a koala be like a regular bear?
Why?
Why?
Because it doesn't have the qualifications. If you've had me before, you've heard that, you know? I mean, I don't have a big joke repertoire. So who wants to go ahead and talk about number one? What's your question? Kids denote number of children ever born to a woman, and let education denote years of education for the woman. A simple model relating fertility to years of education would be your kids is equal to beta sub 0 plus beta sub 1 times education plus some error term. Yeah? Error as in we're estimating the population here. What's in that error term?
I said health problems.
Good. Health problems. Yeah, what else?
Income,
Yeah, okay.
age, and lifestyle.
Age, family background, whether they came from a big family or a small family, right?
Where you
Certainly
got your
anyone.
education?
What?
Where you got your education?
Yeah, okay, yeah. Yeah, there's loads of them. Yeah, we just named a few. There's loads of them. Are these likely to be correlated with education?
No,
No,
less likely.
no. Anybody feel differently? Income, isn't that correlated with education maybe? You got more income, you're more likely to go to get educated, right? How about if you got like 10 brothers and sisters? Maybe you're more likely not to get educated if you got 10 brothers or sisters. My guess is is that they could very easily be highly correlated to education, yeah? Your health, your age. I mean, nowadays, more and more women are getting educated, but 30 or 40 years ago, not so many. Yeah? So I'm sorry, Drake, I'm going to have to disagree.
I understand.
I think these things could easily be tied up in education. So what would we have to do? If we really wanted a model that predicted your number of kids, we would have to pull those things out of U, the error term, and put them explicitly in the model, right? As in beta sub 2, beta sub 3, beta sub 4, whatever, right? A multiple regression model. Okay, how about Will a simple regression analysis uncover the ceteris paribus effect of education on fertility? No, and not if we just said that those things are correlated. I mean, I said that they were, you know, you could disagree, but if they're correlated, it's not going to be a very good ceteris paribus effect of education on fertility, is it? How about number 2? Did you guys get number 2? No? Nobody got number 2?
We couldn't figure out what it was asking for.
Well, what it was asking for was, oh, sorry. Let's do this. What they were saying was, how do you move this line without it affecting beta sub 0, right? We're just changing the line. We're not changing the slope. So for example, if I go to my email here, I did this while you were in your groups. Sorry. So we have a regression equation here. Y is equal to beta sub 0 plus beta sub 1 times x plus u. If you were to add and subtract alpha sub 0 from the right-hand side of this, you could have y is equal to alpha plus beta sub 0 plus beta sub 1x plus u minus alpha sub 0. So we haven't changed anything, have we? We've just taken a constant and added it and subtracted it from this equation up here. The new error term in this equation is u minus alpha sub 0, u minus alpha sub 0 here. And we know by assumption, I think it's what, number 1 or 2 or something, the expected value of your error term is 0. Therefore, the new intercept in this regression equation is alpha plus beta sub 0. So the slope is the same. All we did was move the line with the same slope. Is that cool? Everybody see what I did? Okay, very exciting, right? Now, how about number 6? Following equation relates housing price to the distance from a recently built garbage incinerator. Interpret the coefficient on log of distance. Is that the sign of the estimate that you would expect it to be?
I said every like 1 input increase in log distance, there's a increase in 0.312. I said I would expect the sign to be what it looks like as being positive because the r squared value is positive.
All right.
It can't be negative. Is it? If it's distance, it can't be negative, though. No.
I can't say it again, Alex, and put your video on.
Yeah, 1 second.
You're muted now. There we go.
There we go. Sorry about that. If the coefficient is for distance, it can't be negative because There's no such thing as negative distance. Is that what it is? Am I completely wrong here? I don't know.
No, the coefficient is the effect of distance from the incinerator on price. It could
Oh,
be
okay.
positive or negative, right?
Yeah, I get that.
Go ahead.
I mean, would it be positive because the farther away from the incinerator, the house has more value?
Yeah. The further you are from this garbage dump, the more your house might be worth. So that's exactly what we would expect. Yeah, the beta sub 1, the coefficient on your explanatory variable is simply the effect on that whatever dependent variable, whatever independent variable you're using. Yeah? So it's exactly right. Thank you, Marco. Do you think that the regression provides an unbiased estimator of the ceteris paribus elasticity of price with respect to distance? Then it says, think about where the city decided to put the thing. Any thoughts about that? See, here what we're trying to do is get you to think. I'm trying to get you to think, understand what we're talking about. Rather than memorize the formula or anything else. I don't want any of that. I want you to think about what's happening here. So, think about the town's decision on where to put the incinerator. Probably they're going to choose to put the incinerator in a fairly low income neighborhood, right? Has that been your experience in your life that the transfer station in your town, it might be maybe not in the nicest of neighborhoods, is that right?
Yeah.
It's down wherever all the manufacturing is and, stuff like that, right? Lumber yards and things like that, right? Well, if that's going to be the case, then there's going to be some correlation between the location and the housing quality, right? Or the housing price. Yeah, which violates our least squares assumptions. One of them, that error term can't be correlated with the independent variable, right? What's number? Oh, what other factors about a house affect the price?
How nice of a house it is.
Say it again. Was that Alex?
I said number of rooms.
Yeah, number of rooms. How old the house is. If there's a park in the neighborhood, right? All this other crap goes into it, right? All right. Everybody happy? Charlie, you look very happy. You're still laughing about my koala joke, I'm sure. I want, let's do two things. We should have a test. We should have an exam. Probably we should have it next week. Probably a week from today. only on the material in Wooldridge 1 and 2 and the math review. Okay? Does that work for everybody?
Yeah.
Yeah, that works.
That works.
I want to talk about this number 3. The following table contains ACT scores and GPA for 8 college students. Students 1, 2, 3, 4, 5, 6, 7, 8. GPA 2.8, 3.4, 3.0, blah, blah, blah. ACT scores 21, 29, blah, blah, blah. 1 digit. Estimate the relationship using ordinary least squares. That is, obtain the intercept and slope estimates in the equation. In other words, we want beta sub 0 and beta sub 1. Can you guys do that? Do you guys know how to do that? Do you guys know what's being asked? Do you remember from statistics being able to do this? How would you go about doing it?
Do you have to find the variance and covariance
Yeah?
and then divide the covariance by the variance of X to get one of them?
Which one?
I can't remember.
That's great. Thank you, James. That's really good. It would be beta sub 1 because beta sub 1 is the slope. So, and the process you just outlined was the ratio of the covariance to the variance, which is the slope of your regression line. So that would be one way of doing it. I was really looking for more tractable. What are you going to do? I'm going to have you guys go do this. So, you know, you could sit down with a pencil or a crayon and a calculator and figure these things out, right? You've got to like get the average of X and the average of Y and subtract them and, you know, and then figure out what the variance is, right? And is that going to be hard to do?
It's gonna
What if you
take a
did
while.
it? Balin, what?
I just said it's gonna take a while.
How are you thinking of doing it? With a pencil?
I would do it with Excel.
In Excel. It shouldn't take you that long in Excel, right? I mean, Excel is your go-to. That's what you guys all were brought up on, yeah? So you ought to be able to just plug the numbers in and then add and subtract and get the understanding of what we're going for here using Excel, right? And then, so why don't you guys try to do that? And then we're, of course, going to do it in R. Just so you have something to look forward to, right? I think doing this exercise, and I think you guys doing it, will help solidify your understanding of what we're trying to do here. Yeah? So why don't you all try and do that for Thursday and use Excel. Use whatever you want. Help each other, get together, talk about it, email each other. I don't care what you do, you know? I just want everybody to have a little bit better understanding of what's going on. And then Thursday, I have all the stuff done. I'll open it up and we'll have a look at what Excel says, and then we need to look at how to do it in R. Okay. How's R going for everybody? That well.
No.
What do you say, Matt?
It's pretty difficult trying to work through it.
The learning curve maybe is a little steep.
Just a little bit.
Yeah. That's okay, though. You guys are all smart. All right. Have we had enough?
I have a question.
Okay.
Are we gonna have to take the exam during like class time? Or is it
That's
whenever?
a great question. What do you want to do?
Whenever.
What?
I think it should be open for longer than class time.
Here's what I'm thinking. Maybe what we should do is not have class on next Thursday, but you guys do the exam anytime you want between like Tuesday after class and Friday.
I think that's a great idea.
That sounds great.
And
Yeah, I like
Would absolutely appreciate that.
but I got to figure out how to do it, gosh, I gotta jump through hoops left and right here,
We can
So
just
that's
not have
what
an
I'm,
exam.
what?
So we can just not have one.
Oh, no, but then how would, you would miss that feeling of accomplishment and the sense of achievement that you get from taking exams and doing well. Isn't that part of the whole college thing?
I think we'd be fine without it.
You think so? How is it going over there at Bonaventure anyway? Is anybody getting sick?
No. Just
well,
one person.
Are they, but they're making you all not have any fun, right?
Yeah, kind of.
So you got to wear a mask when you go to anywhere,
Even outside.
even outside.
Yep.
You think we'll make it to Thanksgiving?
Yes.
How many are going to come back in the spring? I should say, how many are not coming back in the spring? Everybody will come back? Is anybody taking investments with me in the spring? They told me that last year they told me they were taking investments away from me and giving it to Amira.
Rather have you.
I'd rather teach it. I'd rather be teaching. I mean, them, they're going to give me like Corp Fin or something like that, But I really like teaching investments. All right. Well, have a look at that problem number 3 and see what kind of stuff you can dig up on Excel. And then think about how to do it in R. And we'll see you all on Thursday.
will you
Sounds good.
email us if the test is gonna be Tuesday or Thursday of next week?
No, I'm going to make it so that you can do it whenever you want.
Okay, Sorry, my mic dropped out then, so I didn't listen to the exact time.
Yeah, but you're still going to have a time limit, 75-minute time limit, but, you know, I'm going to say just open it and close it, and you open it when you want, and then you got 75 minutes. And we'll continue having class Thursday and Tuesday, and then, but the material will only cover up through this chapter and what we did before. Okay? Any other questions? All right, everybody, thanks.
Thank you.
Good one.
You're muted.